A solid sphere of radius 6 centimeters is melted and recast into spherical balls of 1 millimeter. Find the number of balls thus obtained and wastage if there is any. Okay, so what is the main concept behind this particular sum? The volume of an object remains the same irrespective of the shape that it is remolded into or recast into. So here we have a spherical ball. Sorry, there is a solid sphere which is converted into spherical balls. So, volume of the solid sphere is equal to volume of all the spherical balls. Okay, now all the spherical balls are of the same diameter. So, let us take the number of spherical balls as n into volume of one ball. Correct. Now, volume of the sphere is given by 4 by 3 pi r cube. So, my radius is 6 centimeters and here I have 1 millimeter. I am going to convert the 6 centimeter into millimeter. So, this will become 60 millimeter. This is equal to this volume of the one ball is 4 by 3 pi. My r is, no, the diameter is 1. So, my radius is 1 by 2. Okay. Now, I have equated both of them in order to find the value of n. We will cancel out the common factors which is 4 by 3 pi. So, we will get 60 cube is equal to n into 1 by 2 the whole cube. N by 8. Okay. Now, what is the value of n? (80 into 60 cube). So, we will find out the final value and see how many balls were made from one solid sphere of radius 6 centimeters. So, you will get the value of n as 1728000. So, that is the number of spherical balls that can be made from that solid sphere. Okay. So, now let us move on to the next sum. You have three solid spheres of diameters 2 cm, 12 cm and 16 cm which is cast into a single solid sphere. We need to find the radius of the solid sphere. Now, it is based on the same concept as the previous one. Volume of the metal before being recast into another shape remains the same if no wastage is mentioned. So, here the volume of three spheres is equal to volume of the single sphere. Okay. Now, if the radius of the new sphere that is formed is capital letter R, the volume is equal to 4 by 3 pi r cube. This radius is what we need to find. Now, what is the volume of the three solid spheres? So, the first sphere has a radius of 1. The second sphere has a radius of 6 and the third sphere has a radius of 8. So, please always check whether it is a radius or the diameter that is given to you. Okay. Now, I will be taking out the common factor which is 4 by 3 pi. I get 1 cube plus 6 cube plus 8 cube. That is equal to 4 by 3 pi r cube. I can cancel out the common factors which is 4 by 3 pi, 4 by 3 pi. I will add this up and I will take the cube root on both the sides in order to find the value of r. So, let us see what we are getting. So, after cancelling out the common factors, I will get 1 plus 6 cube plus 8 cube. Here I have opened the brackets. So, I will get the r cube value as 729. Taking the cube root on both the sides, we will get the value of r as 9 centimeters. So, always remember the volume will remain the same, and unless any wastage is mentioned, suppose they are mentioning that while converting a sphere into some spherical balls, this percentage of the metal was wasted. So, you need to subtract that percentage of the metal from the original one before equating the volume. So, let us do one sum based on this particular concept where the wastage of the metal is mentioned to you. Now, here I have made a small change to the question. I have mentioned that 30% of the original volume was lost. So, which means that only 70% of the volume of the three spheres was used in making a single sphere. Okay. So, 4 by 3 pi into 1 cube plus 6 cube plus 8 cube. Out of this volume, only 70% was used, 30% was gone. This is equal to volume of the sphere. I keep telling cube, but yes, sphere. Okay, so now cancelling out the common factors, you get 70 by 100 into 729 is equal to r cube. Okay, so you will get, so here you can see that 70 by 100 is 729 will give me r cube. So this is the value I am getting, not a very good value for finding out the cube root. So I have left my cube root in the form of 510.3 the whole raised to 1 by 3 centimeter. When the question is being asked in the question paper where wastage is mentioned, they will ensure that this number is a proper cube. If that number is not a proper cube, they will give the value of the cube root. Okay, so I hope you have understood. So which volume to take, and that the concept that the volume will not change unless some wastage is mentioned. A sphere of diameter 6 centimeters is dropped in a right circular cylinder partly filled with water. If the diameter of the cylinder vessel is 12 centimeters, if the sphere is completely submerged in water, find the level of water rise. Till now, we were doing sums in which the volume remained unchanged when it was converted from one shape to another. Okay. This kind of particular sum is based upon the concept that the volume of water that is displaced is equal to the volume of the solid that is immersed in it. Okay, now I will explain the concept. I will break down the sum into multiple parts. Let us take the example of a 4-liter bucket. Any volume is okay. I'm just randomly taking a number 4 liters, and this is a bucket, by the way, and there is water inside the bucket. Okay. Now, what is the maximum capacity of the bucket? The maximum capacity of the bucket is up till here, which is 4 liters. Now, you have, in your houses, you have seen buckets which is completely filled with water up to the brim level. If you are taking a big stone and putting it in water, what will happen? The water will obviously overflow, right? What is the reason? Because that stone has to have some space inside, so that much of water cannot stay inside the bucket because the stone is already displacing that water, so water will flow out. Now, what is the volume or what is the quantity of the water that is flowing out? The quantity of the water that is flowing out has to depend upon something. It cannot just freely flow. Okay, so the quantity of the water that is flowing out will depend upon the volume of the stone. Correct. So the volume of the water that is flowing out of the bucket is dependent upon the volume of the solid that is dropped into it. Okay, this I am talking about a bucket that has been filled up to the brim. Let us talk about the bucket that has not been filled up to the brim. Suppose you have a 4-liter bucket in which water is filled only up to this level. Okay, nothing. I am not going to mention any measurements or anything. I am just telling you that it is not filled up to the brim. Let it be a random height h. When I am dropping the stone into water, because it is heavy, the stone will completely get immersed in water. What will happen to the water? Just like in the previous case, water has to make way for the stone or make space for the stone. So the water, what will it do? It will adjust itself. That is the most beautiful thing about liquids. Liquids can take the shape of the container. Liquids can adjust itself in order to have a solid immersed in it. Now, depending upon the density of the liquid that is used, this will change, but that is physics. Thankfully, this is maths. We are using only water. So, what will water do? In order to allow this stone, the water will rise a little. Okay. Now, suppose it is rising by a height x. Okay. Now, till here you had water. After dropping the stone, the water went up to a level x. Now, this water has a volume, correct, which is given by the shape of the container, whatever be the shape of the container, cylinder, cube, sphere, whatever. Now, there is a volume for the water. Let us call it as VW. The stone has a volume. Again, I told you water cannot rise indefinitely. There has to be a criterion. So, the volume of the stone, or in order to make space for the stone, that much quantity or volume of water rose up. So, the volume of this water is equal to volume of the stone. So, basically, very scientifically or mathematically speaking, volume of the water that is displaced is equal to the volume of the solid that is dropped into it. Okay. So now let us do this sum so that you get clarity about the concept that I am talking about. So I have written down the steps for you. First, it is a concept. What is the concept that we are using over here? Volume of the solid that is dropped or taken out is the volume of the water displaced. When I told you that when I'm dropping a stone into the water, same quantity of water is displaced as that of the volume of the stone. It's the same with if there is a stone already inside the water, and if I'm taking out, what will happen to the water? The level will go down. Again, that is equal to the volume of the stone taken out is equal to the volume of the water that went down. Okay. So the solid here is a sphere whose volume is given by 4 by 3 pi r cubed. The diameter is given to be 6 centimeter. So I have taken radius to be 3. So this is what I am getting. I am not solving it because that is not my final answer. I need to equate it to something else. I am leaving it there. Now next, solid dropped, water has risen. The water is rising in a cylindrical vessel, correct? Whose volume is given by water. That is not a solid. It takes the shape of the container. Volume is given by pi r square h. Okay, so 22 by 7 into 6 into 6 because the diameter of the cylinder is 12, radius is 6 into h. H is the height of the water that has risen up. Now let us equate both of them and find out the value of h. So I have equated both the values over here and you can see that I am getting h. All the terms are getting cancelled out 1 centimeter. What a beautiful answer. Okay, so now when you have actually having numbers like this with everything gets cancelled, it is a damn relief actually. So I hope you have understood the concept. Now, two hemispherical bowls A and B of internal radii 10 centimeters and 5 centimeters were used to fill water into a bucket. A was used twice and B was used 3 times. After dropping a sphere V1 into water, volume of the water rise was found to be equal to half of the volume of water in the bucket. Find the radius of the sphere. Okay, so in the sum, which is the concept that is being used, the volume of the solid that is dropped into the water is equal to the volume of the water displaced. In addition to that, there is one more concept that is being used in the beginning. The volume of the liquid will not change unless there is any wastage, or volume of the solid from one shape to another will not change unless there is any wastage. So we have two parts. One, there is a bucket which is being filled with water using two hemispherical bowls. One of internal radius 5 and the other of internal radius 10. Now, for the capacity of the hemispherical bowl, we know that only internal radius matter. So, the volume of the water which is taken by these two hemispherical bowls to be dropped into this bucket will be equal to the volume of the water inside the bucket after they are being dropped into it. That is our first part. In the second part, somebody dropped a sphere V1 into the bucket and what happened? There is a water rise. So let us break down the sum into two different parts and see the concept that is applied and how to solve each part. Okay. So now I am going to do the first part. The first part, our concept is volume of water will not change even if the container changes. Assuming there is no wastage, okay. Same as the volume of a solid will not change when we are changing the shape from one to another. So this bucket is being filled with water. How is it being filled? Using two hemispherical bowls, each of volume given by 2 by 3 pi r cubed. So the bowl A has a volume of 2 by 3 pi into 10 cube and the second one has a volume of 2 by 3 pi into 5 cube. You are carrying water in two bowls and putting into the bucket. Very basic thing. How many times was A used? A was used twice. Okay, 2 times. And B was used 3 times. So just imagine when you are having a sum like this, if you want to break down the sum into parts, suppose you have a bucket over there and you have two glasses, one of volume, two different volumes. You use the first glass twice and the second glass thrice. Now in this case, instead of the glass, we have two hemispherical bowls whose volume we can find by using the formula. So the first one was used twice and the second one was used thrice. Now when you add up this value, what you get is the volume of the water that went into the bucket. So I have gotten the value to be 236.96. See guys, I know it is a very weird value and this is a sum that I just made up because so as to get an understanding of both the concept, I try to join them up. So because I have given the values, you are getting a very weird number like this. But I think if you are getting it in the question paper or if you are getting it in a proper reference book, you will get proper numbers because they have already worked out the solutions and then they are showing you. So forgive me for giving me such random numbers, but I want you to understand the concept. So this is the volume of water that is in the bucket. Now the second part. The first part is over. After dropping a sphere V1 into water, so what is my second concept? So this part is over. So my second concept is volume of the solid dropped is equal to volume of the water displaced. I am not writing the whole thing. Okay, you already know. What is the volume of the solid dropped? The solid is a sphere. So my volume is 4 by 3 pi r cube. Okay. Volume of the water displaced. Because we do not know the shape of the vessel, they have given us another hint. The volume of the water displaced was found to be equal to the half of the volume of water in the bucket. So the volume of water rise is half of this value. So and 6. Now you can find the value of r cube and then find the value of r. Suppose you are not getting a proper cube root, you know what you should be doing. Suppose in any sum, see, it is not necessary that it can happen only with the sums that I am giving. Sometimes, you know, in certain cases, when you are writing for the board exam, sometimes it so happens that you get very, very weird numbers whose cube root or square root we have to find. Square root you cannot help, you have to do by long division. But thankfully, cube root is not so easy to find. Suppose you get a number like this. You have to find the cube root. You don't have to find it. Just write raised to 1 by 3. So any number which does not have a proper cube root or you are not able to reduce a number into the minimum form, just keep it as raised to 1 by 3 form unless they have given you the value in the question. Okay. So in this case, we are equating both of them and this is what we are getting. Now let us find the value of r cube. Okay. Okay, fine. I am getting the value of r cube as 28.2736. So you can write the value of r is 28.2736 the whole raised to 1 by 3. So I hope you have understood both the concept very clearly. Volume of a solid or a liquid will not change unless a wastage is mentioned, and you also know that volume of a solid dropped is equal to the volume of the water displaced. Volume of a solid, when it is cast or remolded from cylinder to cone or to something else, the volume will not change. Similarly, that of a liquid, it takes the shape of the container, and volume of the liquid stored in a cylinder will be the same as the volume of the liquid that is being transferred to another solid, right? It is just that the formula or the shape in which the liquid is stored will change. 27 iron spheres, each of radius r and surface area s, are melted to form a sphere of surface area S1. Find the ratio of the surface area and the radius r. Okay. So what is the concept? The concept is that the volume will remain the same irrespective of the shape. So concept is volume remains same. 27 iron spheres. So here both they solid. So 27 iron spheres has a volume of 4 by 3 pi r cube, where r is the radius of one iron sphere. Now it is given that the radius is r, so I have put r over here, and surface area s. Okay, fine. They are melted to form a sphere of surface area S1. So this is equal to the volume of the sphere 4 into pi r cube. Okay. Let me cancel out the common factors, which is 4 by 3 pi and 4 by 3 pi. Or I can say that 27 into r cube is equal to r cube. Or I can say that r cube by r cube is equal to 27. If I am taking the cube root on both the sides, I will get r by r is equal to cube root of 27, which is 3. Or I can say that the radius of the big sphere is 3 times the radius of the small spheres. Okay, so we have got a relation between capital letter R and small letter r. Okay, so now another important thing that is given to us is that the surface area of the first sphere and the 27 spheres and surface area of the bigger sphere is given to us. So what do we need to find? We need to find the ratio of the surface areas. So in the previous sum that we did, we have learned that when we are finding the ratio, we do not need the absolute values because the common terms will get cancelled, right? So here, what is the surface area of the small sphere equal to? It is 4 pi r square. What is surface area of the bigger sphere equal to? It is 4 pi capital letter R square. We need to take the ratio of both. So let us take the ratio. It is 4 pi r square, surface area of the big sphere by surface area of the small sphere. 4 pi and 4 pi will get cancelled. I will get r by r the whole square. What is the value of r by r? It is 3. So 3 square is 9. So I will get the ratio of the surface areas as 9. Now next part, what do we need to find? We need to find the radius r. It was my mistake. They have not asked us to find this radius. They have asked us to find the capital letter radius r of the new sphere. So that we have already found, which is equal to 3r. Because no absolute values are given, this is the only value that we can find. Okay, so we have done both parts of the sum. I hope this is clear to you.